All right, the next unit, we are getting ready to embark on all things graphing. And so yesterday you graphed lines in a lot of different ways. Now we're going to start talking about finding intercepts and kind of understanding how the line equation works. Okay, so first, on this first page, it says finding the x and y intercepts of a line given the equation. All right, so here's your equation. How do you even know that's a line? Okay, I actually think this is really important. This is not a line. This is not a line. This is not a line. Okay, this is a line. That is a line. And this is a line as well. What you'll notice about the lines, whoa, wow, lines versus non-lines is that the exponents are not to the power of 1. Okay, if you were actually to change that, that would be x to the negative 1. Or if you multiplied both sides by x, you would get xy equals 1. You can see that even though they are to the power of 1, they're not, they are multiplying by each other rather than adding to each other, which is not linear. This is actually a hyperbola. Looks something like this. Whoop, whoop. Okay. Lines, look, to the power of 1, to the power of 1, to the power of 1. All right, that being said, when you're looking at a line and you're graphing it in the coordinate plane, okay, this is x and this is y. We are soon going to change y to the function of x. We're not there yet. That's going to happen in this unit. But this is your x, this is your y, okay? No matter where your line goes, okay, whichever direction it goes, okay, it is going to have, if it crosses the x and y axis, it's going to cross at a certain point, and those are called the intercepts. I know you know this. I know I'm kind of going backward just to make sure we're all on the same page. All right, so here we go. There's a couple ways of doing this. Find the y-intercept and x-intercept of the line. The easiest way to do it is, notice, this is going to be just a temporary line. This is not this line, but notice, okay? X-intercept is where a line crosses the x-axis. A y-intercept is where it crosses the y-axis. Now, what do you know about x at the y-axis? At the y-intercept, rather, and the y-axis. Look, to get to any point on this y-axis, x is equal to 0. That is key. So this point is 0. Let's just name it B. We'll call it B. This point, on the other hand, is some value here, but y is always going to be 0. So I'm going to just say we went A and 0. So using the fact that at the y-intercept, x equals 0, and at the x-intercept, y is equal to 0, we're going to be able to find the points very quickly. Okay, I'm going to try to erase this. We shall see how this goes. Ooh, I'm actually getting a tablet. The school is getting me a tablet, so hopefully I get a little better at drawing things. I'm a little better, but I have to hold the back of my laptop really weirdly to do this. All right, so here we go, x and y. Now let's graph this line. So the quickest way to graph this line is to take, well, rather not to take, but to set x equal to 0 and y equal to 0 and plug them in. So let's plug in x equals 0. We're going to go negative 0 plus 2y equals 8. 0 goes away, 2y equals 8, so y is equal to 4. Okay, I'm going to erase that, so you go ahead and grab it if you need, okay? All right. The second one, we're going to plug in y equals 0. So we go negative x plus 2 times 0 equals 8. Well, 2 times 0 is 0. 0 is a nuclear bomb. Cancels everything out. Well, the opposite of x is 8. We don't want the opposite of x. We want 8. We want x. So we need to multiply both sides by -1, or just think, if the opposite of x is 8, then x is equal to -8. A lot of people like doing this, though. Okay, x is equal to -8, and now you have your two intercepts. And that's it. Graph those 2 points, and you're good to go. So 0, 4, 1, 2, 1, 2, 3, 4, and -8, 0. Right here. And connect them. Now, you're going to notice I really can't do this very well, so I apologize. Hey, actually, what am I talking about? That was pretty dang good. Okay, so this is that line. Moving on. Let's see. The equation of the line, well, actually, the title of this is Graphing a Line by First Finding its X and Y Intercepts, which is basically what we just did. Okay, so it's a good example, second example. Here's the equation of the line. It says find the X and Y intercept and then use them to graph the line. Okay, now how is this different? I think, because it wasn't about graphing the line here. I get it. In other words, when you answer this one on Alex, you're going to answer with this 0, 4 and -8, 0. Like they're just asking you to name these. I didn't need to graph it, but I would naturally graph it anyway. That's like it's really how I understand it. So I'm not sad about it. I guess that's what I'm trying to say. All right, now we're going to graph it. So again, we're going to use the fact that at the x-intercept, y is 0, and at the y-intercept, x is 0. We're going to plug in those two values. And I have a little more room here, so this is kind of cool. So we're going to go 2 times 0 minus 4y equals -4. 2 times 0 cancels out. -4y equals -4. Well, look, don't need to divide by -4 because you can think this through. Look, -4 times a number is equal to -4. What's that? 1. Okay, let's try the next one. Let's plug in a 0 for y. So 2x minus 4 times 0 equals -4. Cancel that out. 2x equals -4. 2 times a number is equal to -4. That would be -2. And there you go. So again, to graph it, simply graph your x and y intercepts. So 0, 1, -2, 0. And then you connect them. And Alex will have you do that. Wow, I didn't connect that very well, but you know what? This is hard. So you guys can forgive me for that. And Alex, she'll be able to do that a lot easier. All right. Okay, so one last discussion about this whole x and y intercept thing. A lot of you guys know how to graph lines in y equals mx plus b. And when you see it in standard form, like this one, you're probably tempted to change it to y equals mx plus b. Well, the fastest way to graph a line in standard form is to use intercepts. But you can tell when it's a good time. Because look, do you see how everything's a multiple of 2? You know that's going to be easy to do. For example, if you're given something like 3x plus 6y equals 12. Do you see how 3 and 6 are actually factors of 12? This is a great one to do by intercepts. Really nice. Now, if you get something else like this, x plus 7y is equal to, how about 3x plus 7y equals 12? None of these are multiples. This is going to be irritating to do. You could still do it, but you're going to get fractions. And that may not be what you want to do. So it might be easier in that case to change it to y equals mx plus b form. I do think it's important to know when to use which one and make some wise decision. A lot of times we cling to one method. By the way, this was my absolute favorite way of graphing lines when I was a kid. Absolute favorite. I would almost do it every time because I loved the power of 0 and how it would just cancel everything out. All right, it says find the slope. Now we're going to get into slope. You need to remember the slope formula for a lot of this, okay? Actually, I'm going to give you the slope formula, which is m is equal to y2 minus y1 over x2 minus x1. The slope formula is great if you don't want to think. It really is great. You could just plug in the points and you're good to go. That means what they give you 2 points, x1, y1, comma there, x2, y2, and then you just plug in the appropriate parts. And I want to do this. You know what? Let me do this in a different color because check this out. I want to make sure you know this is the one place where things can go bad on the slope formula. Okay? It's right here. You need to make sure that when you plug in your points, you plug them in exactly the way the formula comes to you. It's y2 minus y1 over x2 minus x1. Now, it doesn't matter. If I give you 2 points, it really doesn't matter which one you choose to be x2, y2, or x1, y1. What matters is that the points are in the right spot. This is a point, that's a point. Okay? That's the slope formula. You write it down, use it, and abuse it. It's fine. But really, what is slope? Slope is equal to the rise over the run. From point to point. Some people don't get this part. From point to point. Think of the slope as a directional thing. It's telling you how to get from one point to the next. It's telling you the change. That's a little fancy little symbol. Maybe you learned it in chemistry. Change of y over the change of x. That is all the slope is. So if you want to think math, and I'm trying to get you to a point where it's always better to think math than to just use formulas. Formulas are great. I used them all my life, learned how to think later. But here's the thing. What it's telling you is start at a point. How do you get to the other point? Well, here's the thing. You have to go north-south first. You have to go Y. You have to go up and down first. Then you go left and right. So if we're starting here, how are we going to get to that point? Think of it as 2 houses in a neighborhood and the lines are streets, and the only way you can get there are streets. So how are you going to get there? You're going to go down 1, 2, 3. So in this case, you're going to go down 3 and over to the right. Which direction, by the way, is down? Down is negative. So we're going to go down 1, 2, 3, and we're going to go in the positive direction. 1, 2, 3, 4. Okay, so the slope is -3. We went down 3 over +4. So the slope is -3/4. Take a look at if we started at this point instead. You don't have to start at that point. Let's call this point 1. How are we going to get from here to here via the streets? Don't say this way. No, no, no. You cannot go left and right first. You have to go up or down. So we're going to go up. We're going to go up 1, 2, 3 to get on that street. And we're up in the positive direction. So we went up 3. And then now we're going to go over to the left 4. That's the negative direction. So -4. It still equals -3/4 because we don't leave the negative on the denominator. That's just ugly. We just don't do that. Okay, so the slope is -3/4 no matter which way you go. If you pick the slope formula, you would name the points first. This is how you're going to do it with the slope formula. I'm going to name that point. That point is 0, 1. This point is 1, 2, 3, 4, -2. Okay, I'm going to call one of these 0.1 and 0.2. Let me call this one 0.1 and this is 0.2. Okay, here we go. We're going to plug it into the slope formula. Okay, so if this is 0.1, this is going to be x1, y1, x2, y2. M is equal to y2, which is -2, minus, this minus has nothing to do with any of the points. It's part of the formula. You leave that minus in. Okay, put the next one in. 1 over x2 minus x1. And you get negative 3/4. And again, if you wanted to change this and call this, I'm explaining a lot in the first one. I will not do this continually. You guys, this is just the first one, just because. Let's say we want to call this one x1 and y1, and this one x2, y2. Check it out. It still works. Let's go. Let's plug it into the slope formula, and we're going to get m equals, look, negative, oops, sorry, my bad, 1 at y2 minus y1. Notice I kept the minus and put the negative 2 in parentheses. This is not that negative. Do not confuse the two. Over 0 minus 4. And look, you still get negative of a negative is a positive, 3 over negative 4, negative 3/4. So many ways to do it. So many ways to figure it out. Name the points, find the slope, count from rise to run, however you want to do it. Here we go. We got points. All right. I'm going to call this one x1, y1, x2, y2. Why? I don't know why I did that. Just because, because they came first. I don't know. It makes absolutely no difference which one you decide to call which. Okay. And we probably should do like this. Whatever. There. Now it looks a little more mathy. All right, here we go. M is equal to y2 minus y1 over x2 minus x1. I highly recommend you keep writing that formula until it's in your brain and memorized. It is a formula that needs to get memorized. So y2, negative 4 minus, that's part of the formula, okay, minus negative 8 over 1 minus 5, x2 minus x1. And this becomes, again, when you have a negative times a negative, it's a positive. So it's negative 4 plus 8, which is 4 over negative 4, or negative 1. Just be careful with the minus signs. A lot of times kids think these minus signs are these, and they are not. The minus sign is in the formula. Leave it in the formula, put the negative number in a parentheses. Okay, keep going. Find the slopes again with the points. Now, all they're doing, the reason why they keep giving you more and there's different ones is because this one is now the slope of horizontal and vertical lines. Now, you might think you need to know that, but you don't. What you need to know is what happens when. Something weird is going to happen when we figure out these slopes. You ready? I'm going to call this one x1, y1, and this x2, 2. So, m equals negative 6 minus 9 over negative 5 minus negative 5. Negative 5 minus negative 5 equals negative 15 over 0. Oh, my Lord. Okay, right now you should be saying, oh, my Lord. Okay, because you cannot have a 0 on the denominator. I hope you guys remember this. You cannot have a 0 on the denominator. It is undefined in math. We don't know what happens when a 0 is on the denominator. This is undefined. Well, what kind of line has an undefined slope? Okay, that is going to be a vertical line. And I'll tell you how you can kind of remember it. Okay, so it's undefined because remember, the slope is the change in y over the change in x. Well, to get from one point on a vertical line to the next, look, the change in y happens. There is a change in y. You jumped up some or you went down some. But look, there's absolutely zero movement on the x. Nothing happens. Therefore, a vertical line has an undefined slope. And that's what you would put here, is undefined. Okay. Okay, you could also kind of tell, you could actually name that line. Notice, see how the x is negative 5 here and the x is negative 5 there? The name of the line is x is negative 5. They didn't ask you that, but that's coming up. All right, let's take a look at the second problem. Find the slope of the line passing through these points. Okay, so you're just innocently going along your merry little way, and you decide that this one is x2, y2, and this one's x1, y1. So we're going to go y2 minus y1 over x2 minus x1. And then you get m is equal to, and look, you got minus minus, which becomes a plus. Oh, wow, check this out. You get 0 over negative 5. What is 0 divided by negative 5? Well, if you have a 0 cookies and you have 5 people, we'll just forget that they're negative at this point. Everybody gets 0 cookies. In this case, you would have 15 cookies and nobody to eat them, and we don't know what happens to the cookies then. Okay, so this is 0. Whenever you get the slope of 0, it is a horizontal line. Because again, it's the change in y over the change in x. What is the change in y here? Absolutely nothing. To get from point to point, we don't have to go up on the y at all. It's 0. And there is a change of x. We moved. Well, 0 divided by anything is 0. So it's a horizontal line. What's the name of the line, you guys? Take a look. It's right here. -3, -3. Oh, check it out. Y is always equal to -3, and that's the name of that line. Okay, let's take a look. Okay, find the y-intercept and the slope of the line. Okay, you got y is equal to -2/3. You have, it says find the slope and y-intercept given in the form of mx plus b. Okay, what you don't realize is there's no x. Or don't realize. What you don't have is an x. Okay, so if you were to actually put this into this form, you would have to put a 0 in for x, just so you know. So the slope here is 0. Whenever you have a y is equal to -2/3, okay, it's a horizontal line at -2/3, okay? So here, though, what it says is find the y-intercept. The y-intercept in this case would be the 2/3. I should have put that, okay, because that's the number that's left here. So it is -2/3. Because there is no slope, the slope is 0, okay? So slope is 0, b is -2/3. Okay, if they gave you y equals 3x minus 1, m is equal to 3, b equals -1. Okay, if they gave you y is equal to -3, it would be y is equal to 0x, because there's no x, so 0 must have killed it, okay? And you got -3, so m equals 0, b equals -3. All right, moving on. I wonder if they're going to give you any, these are all horizontal lines. Sorry, I'm just wondering. They're going to give you a vertical line. What if they gave you x is equal to 2/3? I'm wondering if they probably won't do this in this particular one. I didn't get to, I didn't keep clicking again and again and again. But yeah, in this case, it doesn't work in the form of y equals mx plus b. So I'm thinking they probably won't do that for a vertical line. We'll just tackle vertical lines in a different way. All right. Find the slope and y-intercept of the line. The easiest way to do that is to put it in slope-intercept form. You can graph anything. It's a nice little fast way with that. So basically, slope-intercept form means you solve for y. Okay, I'm going to write that down. Solve for y. That means get y by itself. So let's do that. Okay, we're going to go 9x minus 3y equals -5. Okay, so we're given standard form. We need to change it to slope-intercept. Just solve for y. We're going to move that 9x over. I would prefer that you guys get to a point where you don't have to show your work. Okay, so I have noticed that some of you in your work do this, and this is totally fine. Minus 9x plus -9x minus 3y equals -5 plus negative 9x. Like I've seen people do this in their work when they were explaining their problems. That is actually really good math, but it's also showing a lot of work. This cancels out and you get negative 3y equals, and I'm going to put the x using the commutative property. I'm going to put the x term here because it matches the mx plus b. Okay, do you see where we are? We're heading into the x plus b. We got to get rid of the negative 3. But you have to divide everything by negative 3. You can't just divide one number, not just the x. So you're going to get y is equal to positive 3x, because negative divided by negative, plus 5/3. The m is 3 and the b is 5/3. We have now put it into y equals mx plus b. Biggest mistake I see is that kids don't seem to get that this piece is the slope and that x is a variable. X is not part of the slope. The slope is only 3, not 3x. X is part of the equation. Anyway, so let's move on. The equation of the line is given. Find the slope and y-intercept and then use them to graph the line. So basically they're asking you to change it to y equals mx plus b and then use that to graph the line. So we're going to do that. Let's do that. Negative 3x plus 6y equals negative 12. You guys, this is where I want you to go with your showing your math work. I want you to imagine that you're adding 3x to both sides. Jump it over the equal sign and change its sign. Like mentally do that and write the next line. You don't need to show your work if you can do it without the work. If you can't do it without the work, please continue to do plus 3x until you get there. But if you can jump at this point, jump as soon as you can so you learn how to show less work. Okay, now we're going to divide everything by 6. I tend to write division just because I make a lot of mistakes with division. Okay, and there you go. Here's my equation of my line. Okay, well, great. This is how you graph a line using the secret code of y equals mx plus b. It's really cool when you think about it, you guys. Literally, you could graph any line in the universe using this formula, okay, on a plane. All you need is this formula. The b is the starting point, and the m is how do you get from point to point to point directions. It's your slope. Okay, so right here it says, hey, start at -2. So let's start at -2. What that means is that you're going to put a point at -2. That is your first point. Then you are going to go. I'm going to go ahead and add a plus here. Okay, it says the directions tell you to go down 1, not make a point. Do both directions first. And remember, we go vertical first, and then we go horizontal. So down 1 to the right 2. Up 1 to the left 2. Okay. Wow, that is really kind of icky. But here, I'm going to move it over just a tad bit. And there you go. There's your line. Okay, remember, starting point, and then count your slope. Count the slope. Okay, notice I could have changed it. I could have gone up 1 and to the left 2. Down 1, over to the right. Oh, I did go up 1 to the left. Down 1 to the right 2. Down 1 to the right 2. So a lot of people just keep counting in the same direction and keep making points. Okay. All right, here we go. Writing an equation of line given its slope and y-intercept. Okay. Y equals mx plus b. What's the slope? The slope is m. What's the b? The y-intercept. They're telling you the y-intercept is 4, and they're telling you the slope is 2/5. So you literally go in and you just erase that m, and you put whatever they told you was the slope. They told you the slope was 4x, and then you go back in and you erase the b, and you put whatever they put was the b, 4. Oh, y-intercept is 4. Slope is 2/5. Sorry about that. Here we go. Yeah. Okay, and then you check it. Make sure you put the right numbers in. Like I didn't. Okay, but I caught it, so that's good. All right, that's your equation of your line. Again, M and B, secret code to graphing lines. All right, here we go. Number 10. It says writing an equation in slope intercept form given the slope and a point. Okay. By the way, we are heading towards one of the most difficult problem they can give you with lines, which is write the equation of a line given 2 points. If you were in my geometry class last year, I made you do this for me on a whiteboard personally. I'm going to have you guys do something similar, but I need to know that you know how to do this. So I'm going to show you 2 ways. I'm going to show you first the way that most all of my students prefer, and then I'm going to show you a second, what feels like a cheater way and much more mathy, like when you get into higher level math. This is the only way they'll teach you. Okay, but I'm going to teach you the first way. The first way is to write the equation of a line. If somebody says write the equation of a line, you write down y equals mx plus b, because that's the freaking equation of a line. That is the formula. What do you need? Seriously, what do you need to name this line? The y and the x stay there. All you need is the slope and the b. Well, what have they given you? They gave you a point, but they didn't, and they gave you the slope. Ooh, well, that's cool. They gave you the slope. Let's plug that in. Y, no, I don't want to go green. I want to go green. Y equals plus b. Okay, let's plug in that 4/3. There you go. Oh, crap. See, now all you need is a b. How can you get a b? Well, they gave you an x and a y. Remember we talked about how any point on a line is a solution. That means you can plug it in and it's true. We are going to plug this in. So where it says -1 for y, we're going to plug in -1 is equal to 4/3 times x, which is -6, plus b. Now look, we have everything here. We can solve for our one variable that we're missing. Make b green. Oh, come on. Make b green. We're going to solve for b. All right. Let's put the 6 over 1. Okay. 3 goes into 6 twice. And you get 4 times -2 is -8 equals -1 plus b. Add 8 to both sides. Sometimes with negatives, it's safer to go ahead and show your work. B is equal to 7. Okay, what does that mean? It means that the equation of the line is erase the m and the b, and we're going to plug them in. We're going to plug in the m was 4/3 and the b was 7. This is the equation of the line. That is most of my students' favorite way to do this. I could never do this. I honestly never learned how to do that as a kid. I don't know why, I just never did. I always used this formula. You have to memorize it, but I always liked this formula. Y minus y1 equals m times x minus x1. It's a formula. I liked formulas. This is a point slope formula. This is the name of it, point slope formula. Whenever they give you a point and a slope, you can use it. Okay, what's key in this point slope formula is that this x and this y are the x and the y in the equation. They are the ones that end up at the end. The x1 and the y1 is the point, oops, put this in red. x1, y1 is the point that they give you. Point on the line. And then you plug things in and solve. And this is how it works. It's really simple. You go y minus y1. What was the y1 they gave us? Now we'll just add a little 1 there. x1, y1 for this side. -1 is equal to slope 4/3 times x minus x1, which is -6. And notice the minus is the minus. It's not attached to the dang number. Don't do that. All right, here we go. So negative of a negative becomes positive. So we can rewrite that as y plus 1. Keep my equal signs in line. 4/3 times x plus 6. Okay, now we're going to distribute y plus 1 equals 4/3 x plus multiply 4/3 times 6/1. 3 goes into 6 twice, and you get 8. Subtract 1 from both sides, and you're going to get y is equal to 4/3 x plus 7. Notice it's the same formula. Same formula. You decide which one you like best. This one feels a little bit no-brainer. This one feels a little bit like you're trying to at least understand the formula. It's up to you. This is the one, though, that they're going to teach you in upper level math. Okay, they're going to expect you to memorize this formula and use it. And basically, you guys, it's nothing more than the slope formula. Look. M is equal to the difference in y's divided by the difference in x's, if you understand that. All right. That's it for this video.